Okay, with 3, you've got u equals to 3 sine x, and you've got v equals to cos x. Okay, so the product of these two then functions means we've got to use the product rule. So du dx, differentiate sine x becomes cos x. So we've got 3 cos x, because that 3 is just attached to it. dv dx then will differentiate cos x, you get minus sine x. Okay, so using the product rule, dy dx is v du dx plus u dv dx. So we get v, which is cos x, times du dx, which is 3 cos x. Okay. And then we've got plus then u, which is 3 sine x, times dv dx, which is minus sine x. Okay. Now, when you've got cos x times cos x, that's like cos x all squared, isn't it? Yeah, cos x times cos x is cos x all squared. So we write this as cos squared x. Okay. When you've got cos x times cos x, it's just cos squared x. Put the 3 in front. The same here. We've got then 3 here, and it's minus 3, and then sine x times sine x is sine squared x. Okay, so we could even factorize out the 3 there, right? So we get cos squared x, take away sine squared x. Okay, and we'll see other results and other ways of writing this at a later date. But there's our final answer there, okay, which we've got the product rule differentiated the function there originally given to us. So finishing off then with d, we've got y equals e to the 4x tan x, okay, so we've got u equals to e to the 4x, first function, and then v equals to tan x. Differentiate that then to u dx is equal to e to the 4x. Remember, e stays the same, but then you've got to times it by the derivative in there, which is 4. So we get 4e to the 4x. dv dx, differentiate tan x. Remember, the result for that is sec squared x. It's given in the formula booklet. So product rule then, dy dx is equal to v du dx plus u dv dx. So v is tan x, du dx is 4e to the 4x, plus u, which is e to the 4x, times dv dx, which is sec squared x. Okay, so then you can see then there's a common factor here of e to the 4x. And then inside then we've got 4 tan x plus sec squared x.